Now we are on study guide part 4. We're going to talk about equilibrium primarily. That's the extra topic we're going to talk about. And so equilibrium means that reaction has to be at a balance. So there's each reaction that proceeds from reactants to products, it reaches a balance point. So therefore, if we have reactants going to products, at some point the reaction will reach an equilibrium, a balance point, when the reaction goes one side the same rate as the other side, and it kind of look at it as a balance, an actual balance you weigh things with. So when rates of the reaction are both the same way, then the reaction is called at equilibrium. Now here's the deal: what happens when we have something here, and when we remove a little bit of the reactant, say this is reactant and this is product. What's going to happen is that this is going to be lighter, and the whole thing is going to be out of balance. Well, all reactions love to be in balance, so therefore balance has to be restored. And the best way to restore the balance is to take some of this mass from here and move it over here. So we're going to move some of this mass from the right side to the left side, and we're going to get the balance restored. So which means that first we have a reaction at the balance, and then we're going to do it, say remove a reactant. In that case, reaction is going to consume some of the product. That's the concentration of product will decrease, and because some of the mass will be used to produce our reactants, and in that case, the balance will be restored. So once again, once we remove a reactant, we make a whole system out of balance. To restore the balance, we have to take some of our mass from the products. We have to consume them and to create some of these. So this concentration of products will decrease until the balance is restored. Now let's look if reactants and products. Reaction is in balance. What if we add a reactant concentration? So we have balance, then we increase this mass. Increase this mass, the balance is going to shift. S2. Okay, third try. Shift. In such a way that to reduce some of this and move some of the reactants to the right side. So therefore, if we increase the reactants, reaction is going to increase concentration of products and decrease concentration of reactants. And vice versa. So reaction is going to move to the right. How about the product side? In this case, we have again our reactants going to products. And our reaction is in balance. The reactants are products. Now let's see. What if we increase concentration of the product? When we increase concentration of the product, then reaction is going to be again out of balance. The balance has to be restored. to a point where it was just like before. And so the only way we can do that is take the heavier part, move to the left to the other part. So if we increase concentration of the products, the reaction is going to shift to the left to make more of the reactant. Now what happens when we have a temperature involved? Exothermic or endothermic reaction. So we have reactants go into products plus heat. We can think of heat as reactants. Therefore, if we increase heat, our balance will have to be restored such that the reaction moves to the left. It's going to consume some of these guys and create more of the reactants. Now, so this is exothermic. What if we have endothermic reaction? In such case, you have heat coming to the reaction. Go into products. If we increase heat, now we're going to have to think of it as a reactants. You're going to have to shift reaction to the right to produce more of the product. So the reaction is going to shift to the right or towards products. Now, if we decrease heat of the reaction, we cool the reaction down, now we have too much on the right side and the reaction is going to shift towards the left to replenish some of that heat by consuming the products. Here's a simple problem. This is problem number 4 of Stay Guide Part 4. In this case, you have a certain reaction, and we say that this reaction is endothermic, so therefore heat is going to be on the left side. And now we have to see whether the reaction is going to shift to the right or to the left. We have part A, predict the effect of the reaction if you increase the reaction temperature. So let's see, we increase the temperature. When we increase the temperature, now think of it as a reactant, our balance is going to be disturbed in such a way that it goes from straight to, once you increase heat, that's the new balance. Therefore, we have to take some of this and move to the right. So therefore, reaction is going to shift to the right towards from reactants towards products. Let's see. Shift to the right. That's correct. Let's look at part B. In part B, predict the effect of decreasing reaction temperature. Okay, so it's, and again, heat is on the left side. It's an endothermic reaction. As you predict the effect of decreasing reaction temperature, see, we decrease it. Let's look, we start with our balance. And then we're going to decrease stuff from here, take it off. Therefore, our balance is going to change. Our mass right here. Therefore, we're going to have to take some of this and move it over to the left side, and therefore to restore the balance. And therefore, we say that the reaction will move to the left, because it's moving to the left, from right to left, towards the reactant side. So shift to the left. That's correct. Let's look at another example. So, Study Guide Part 4. Problem number 3, we have a reaction that we're working with. Let's see. We'll look at Part B. Predict the effect of condensing H2O and removing from the solution. So we're removing this over. So we start with our balance. And then we removed some from here, therefore the balance is going to be shifted. And to restore the balance, I have to take some stuff from the right side and move it over to the left side to create our balance again. To that regard, we see that we're moving material from the right side, reactant side, from the product side to the reactant side. Therefore, reaction is shifting to the left. So as we look here, reaction will shift to the left. So that's correct. Now let's look at part D of problem 3, part 4 study guide. What's going to happen when we remove H2 from the reaction mixture? We look at H2 is on the right side, so the reaction is at equilibrium. Now what's going to happen? We're going to remove H from the solution. It's a gas, not a solution. Well, it is a solution. To so this is going to be lighter side, so balance is shifted as such. I don't know what to restore the balance at this point is to move stuff from the reactant side towards the product side. So as we're doing that, we're shifting from left to right to restore my balance. We're going from left to right, so therefore we'll shift towards the right. And that's correct.